talking about what empirical formulas are, and we did an example using empirical formulas and glucose, C6H12O6, as the molecular formula. And we said that CH2O was the empirical formula. Now, here's the interesting part. And you already figured this out, I'm sure, because you're clever critters. More than one substance can have the same empirical formula. Duh. It's a ratio. So C2H4O2, which is a molecular formula, has the same empirical formula as glucose. It's not glucose, it's a different substance. It behaves differently, but it can have the same molecular or same empirical formula. So we can have multiple things that have an empirical formula. One of the things I always like to do on a test here is to say, okay, which one of these could not be an empirical formula? Okay. So are there any of those that could not be an empirical formula? The first two couldn't be an empirical the first two are empirical formulas. That can't be simplified. Backwards, sorry. And you got me. These two are already empirical formulas. They're as simplified as they can get. This one could not be an empirical formula because that can be simplified. Okay? So if something is, if the subscripts are capable of being simplified to a simple whole number ratio, it's a molecular formula. Those first two are not. And of course we could do all kinds of funky stuff with prime numbers. Wouldn't that be fun? But not right this instant. Determining empirical formula. This is how we actually use percent comp, Gesundheit. When an unknown substance is discovered, what you come back with is a percent composition analysis. And we can break that down to mass composition and look at a ratio. It sounds much tougher than it is. So let's just practice one, shall we? And we can actually we'll do this one, but we'll do it by hand. This is the one that's illustrated in your slide, but we're going to walk through it by hand. So some unknown sample comes back. And this unknown sample, we're told, is 78.1% boron and 21.9% hydrogen. This is all the information you get from, the Mars rover or whatever. Well, to start to think about this, we make this sort of imaginary 100-gram sample of this stuff. So we think, okay, if we had 100 grams of this, how many grams of that would be boron? How many grams of it would be hydrogen? Well, that's easy. In a 100-gram sample, we would have 78.1 grams of boron, and we would have 21.9 grams of hydrogen. Okay, cool. Do you smell a factor label in the offing? You should. I'm going to move these up. Okay. What we want to know is, in a 100-gram sample of this stuff, how many moles of boron would we have and how many moles of hydrogen would we have? So we have to go to the periodic table, and we're going to put in our molar masses. And we want to know, like I said, how many moles of boron, how many moles of hydrogen. Okay, so units in chemical down in the next square to cancel. Grams of boron. Up here, moles of boron. 1 mole of boron is how many grams of boron? Who's swift with the periodic table? 10.81 grams of boron, okay. And what do we get for moles of boron then? 7.81 divided by, I'm sorry, 78.1 divided by 10.81. 7.22479, etc. Okay. Awesome. Well, how many moles of hydrogen do we have here? Again, grams of hydrogen per mole of hydrogen. 1 mole of hydrogen is how many grams of hydrogen? 1.01. So 21.9 divided by 1.01, what you got? 21.68316, etc. moles of hydrogen. Okay. So is this B7.2 H21.6? No. You can't have subscripts that are decimal. Subscripts are always whole numbers. So what we're looking for is a subscript here. We're looking for an empirical formula. How do we get that from here? Well, the easiest thing to do is to say, all right, whichever one of these there are fewer moles of, we'll call that 1. And we'll say, well, for every 1 mole of boron, how many moles of hydrogen are there? So the way that looks in practice, shrink this, is we say, okay, well, the subscript on boron is going to equal. We divide everything, basically, by boron. So that's 1. Okay. The subscript on hydrogen is going to equal the number of moles of hydrogen divided by the number of moles of boron. So for every 1 mole of boron, how many moles of hydrogen do we have? So we'll take that divided by that. We get 3.0012, etc. So do we write BH 3.00, etc.? No. It's just BH3. Okay? It's BH3. And the number that you're going to get for whatever is your the thing that there's more than 1 mole of should be within 100th or less of a whole number. If it's not within 100th or less of a whole number, you have a larger issue. Okay? So let's practice one where we have a larger issue. Let's say you're given a substance, you are told that something is 69.9% iron and 30.1% oxygen. Okay, great. What's our first step in figuring out the empirical formula? We want to know their mole ratio. We want to know how many moles of iron there are to how many moles of oxygen, because that's what those subscripts show us. So to figure out how many moles there are, we have to make a magical 100-gram sample. Okay? So in 100 grams of this stuff, how many grams of it would be iron? We would have 69.9 grams of iron. and we would have 30.1 grams of oxygen. Okay, grams of iron, grams of oxygen. So I'll let you go ahead and do the math yourself on how many moles of each there are. Forgot to record all of that. Okay, so you can't have an O1.5, that's not legal. If you double them both, you get Fe2O3. And that's of course the empirical formula here. And we know that Fe2O3 is an ionic compound, so we also know that that's the formula. It's a little bit different if you're using molecular compounds, because they can have all kinds of wacky, crazy molecules. Okay, what I'm going to do now, I believe there are a few percent comp problems in your homework. I want you to practice them. For tomorrow, there's going to be a FIP quiz. Okay? You take it before you walk in tomorrow. You're on your own to take it. If it seems like we're compressing a little bit, we are, because we're sorely behind at this point. So you've got time now to practice. You can take your FIP quiz as soon as you feel ready. I am tutoring tonight. If anybody wants to start doing makeup naming quizzes, I will be printing naming quiz version 2 and 3. Well, just 2 tonight. Nobody should be taking more than 2. But if you need to do naming quizzes, you can come do that. Other than that, the FIP will be up by tonight. So that's 2, 3, 15 by the time I go to bed, whenever that may be. And you are responsible for taking it before you walk in tomorrow. So, and it'll be relatively short, but it'll cover some percent comp and some molecular empirical stuff. Okay?